Hi, and welcome to the video on the calorimetry lab calculations. So I just want to go over some calculations for the data, and then I'll also go over for problem 6, post-lab question number 6. All right, so in your data table, this is the one for walnut, so your numbers may be different if you're using the Doritos or the marshmallows, but there are a couple of calculations that you need to do. First, you need to calculate the mass of the food that was actually burned by subtracting the initial mass and the final mass of the food. So, and this number, this value that you get here, you're going to use that, you're going to save that for the end, but you do need to calculate the mass of the food burned by subtracting these two. The next calculation that you need to do, there's no space for it in this table, but you are going to need it, is the mass of the water. So to get the mass of the water, you're going to subtract the mass of the can in water and the mass of the empty can to get the mass of the water. And again, there's no space in the table, but you do need that value. Finally, the delta T, or the change in temperature, you're going to subtract the T2 minus T1, right? So your final minus your initial, and you get your delta T. All right, so now the next calculation is to get the heat. You're measuring the heat absorbed by the water. So all of these values should come from water. So the mass of water that you got here, it's going to go in for your mass. You're not using the mass of food here, you're using the mass of water. Your specific heat of water, remember, is 4.184 joules per grams degrees Celsius. So that goes there. And your delta T you get from there. Okay. So you're going to plug in these values into your Q equals MC delta T, and you're going to get the heat absorbed by the water. Now the heat absorbed by the water is equal to the heat lost by your food. Next thing, to do the conversions. Right now your heat is in joules. To convert it to kilojoules, you just divide this number by 1,000. Then you're going to convert your heat into calories, and to do that you're going to divide by 4.18 or 4.184. And finally, the last thing is to get the energy content in calories per gram, so you're going to divide your energy in calories by the mass of the food. So remember when I said to save this for later? This is where this comes into play. So you're going to divide this, the number that you get here, by the mass of the food that you got up there. All right, so if you need to rewind the video, you can do that, so you can go over these calculations and check your work. Now I'm going to discuss with you how to do the calculations for question number 6. So question number 6, there's some like pre-work you kind of need to do first, and really it's just about converting the energy that they gave you into joules. So they give you the energy of chocolate. It's 5 calories per gram. The first thing you want to know is what's the calorie in a 0.400 gram sample of your chocolate. So to do that, you're going to multiply the calories per gram by the mass of the chocolate. So that would look like this: 5 calories per gram times 0.400 gram. And that's going to give you the calories of that piece of chocolate. After you have the calories of that piece of chocolate, so now you have your energy of that piece of chocolate, you're going to convert the energy of your chocolate sample from calories to kilojoules and from kilojoules to joules. And you're going to do that by multiplying the calories, so that number, by 4.184, and then you get the number in kilojoules. Once you have that number in kilojoules, you're going to take that value to convert it to joules by multiplying that by 1,000. All right, at this step here, you should have the energy of your chocolate in joules, which is what you want. And remember, the energy of the chocolate is the heat that the chocolate would release, which is equivalent to the heat absorbed by the water in your calorimetry experiment. So if you take your piece of chocolate and you set it on fire, it's burning, okay? And then you have your container of water up here. The heat energy released by that piece of chocolate is going to be absorbed by the water. Now, notice I don't have a negative sign on either side, and that's because I'm using the expression released and absorbed. All right, so those descriptors tell you what the sign is. If this is being released by the chocolate, we already know the sign is negative, and this is being absorbed by the water, we know the sign is positive. So I actually don't need to worry about putting signs here because I wrote that in my words. With that being said, this value, which is the heat, remember you got from up here in joules, you're going to take that value because that's your heat of, absorbed by the water, and you're going to move it to the next step, which is your heat of water is equal to the mass times the specific heat times the change in temperature. So let's talk about the mass first. The mass, remember, they don't give you the mass here. It's sort of a little trick, but we saw that when we did our practice. But they do give you the volumes. Okay, of the volume of water. And we know that the density of water is 1 gram per milliliter. So if they give you the volume in 50 milliliters, well, what would the mass be? The mass is going to be that same value, but in grams, because the density of water is 1 gram per milliliter. So one milliliter of water would weigh 1 gram. 50 milliliters of water would weigh 50 grams. So you actually do have the mass. So that number you can plug in to here, okay? So 50 is your mass. Now the specific heat is a constant, 4.184. And what you're going to solve for in this case is you're going to solve for delta T. Because you have your heat from the previous step, you have your mass from the volume, you know this constant, so you're solving for delta T. Once you have delta T, your change in temperature, then you can use delta T equals TF minus TI to get your final temperature. So you'll have this number from the previous step. Your initial temperature, they tell you, is 20 degrees Celsius. So TI is 20, okay? And you have your delta T from the previous step, so you use that to solve for your TF. All right, I hope you found this video helpful. If you need to, send me a message in Schoology. You can also rewind it, sort of look through this stuff again. All right, that's it for this video, folks. Have a quality day.